I want to welcome everyone to this IPM Toolbox webinar. Very interesting one. Looking forward to it. Supporting New York field crop growers for the 2029 Neonicotinoid seed treatment regulations. So it's a big topic. Scott McArt at Cornell Department of Entomology and Alejandro Calixto, director of the Cornell IPM program, are our speakers. And there's a little bit of a bio here. Both of them have a lot of experience in this work and have been spending a lot of time talking to other organizations about these regulations, other states. I also want to acknowledge the funding, which is through the Southern IPM Center from the USDA's National Institute of Food and Agriculture, the CPPM program. We have a poll up, and we'd like you to all to whiz through that and answer some questions, and then we'll do a similar poll at the end that will help us, do a better job or do a good job or whatever on future webinars. So that somewhat and moderately knowledgeable is the bulk there. Moderate and high impact is about 2/3 of the responders. Moderately and very and extremely knowledgeable. So thank you. I am going to pass this right off to Scott McArt and let him begin his presentation. Oh, if you have questions, please use the Q&A feature that you should find across the bottom of your screen, and we will monitor that, but also chat. Thank you. Go ahead, Scott.
Okay. Well, thanks for having me here, and thanks for joining on this lovely Tuesday morning. A little bit nicer weather than yesterday, so good things going on, at least outside where I am right now. So what I'm going to do is give you guys a little bit of an intro to what happened with the lead up to this legislation, and then I'll hand it over to Alejandro, and he will talk about what's going on since this legislation has been enacted and the lead up to 2029 when the regulations will actually take place. So let's jump into it. All right, so I've been starting a lot of my talks recently with this slide, and I think it's really, it shows what a lot of the US looks like if you fly over it, right? So this is a photo that I took out of an airplane a couple of years ago, somewhere over the Midwest. And I think it's really true, and anyone can really see this, that the way we grow food is impacting biodiversity. It's impacting the land that we all live on. This is very easy to see. And it turns out that, again, it's not that hard of a leap to say, well, of course, this is impacting the insect populations, the bird populations, the other wildlife populations that are out there. So if we go from a photo to actually some data on this topic, we know that pesticides actually predict continent-wide declines of hundreds of wild bee species in the US. This is a paper from my colleague Melissa Guzman, who is here in the Cornell Entomology. She took all of the iNaturalist data that has been entered over a 20-year time period between 1995 and 2015 and looked at whether bees of over 1,081, well, it was 1,081 species of bees that had enough data to look at this question. And she looked at whether bees are actually declining, so they're being lost from certain areas, and what the best predictors at the landscape level are of those things. And what you can see here, if you guys can see me scrolling with my cursor, is that 4 families of bees are actually declining significantly. The other ones are declining, but not significantly. You can see the error bars overlap the dashed line here. So 4 of those families are declining significantly, and the best predictor of declines is pesticide use, specifically use of neonicotinoid insecticides and pyrethroids. So this is one data set. There's many other data sets that show the same thing, basically just showing you something fairly similar to what the photo I was just showing before is trying to convey that yes, the things that we are doing are absolutely impacting biodiversity. On the managed bee side of things, this is the current situation. So we have 30 to 56% of US honeybee colonies have died each year since 2011. If there's any beekeepers in the audience, you know that last year was the worst year in recorded history in the US. 56% of colonies in the United States died last year. That's what's shown in this red bar. This was when CCD, or colony collapse disorder, was first discovered. We thought, wow, colony losses are really bad. That was around 35% colony losses. Now you can see it's not getting better, it's actually getting worse. So now we're up above 50% colony losses. On the flip side, all right, let's take the other view of this particular topic. I think we probably have many farmers in the audience right now, and you guys know just as well as I do that farming is getting more expensive. So this is the best data that we have from New York to date. This is our 5-year ag census between 2017 and 2022. And you can see across the board the cost of feed, fertilizer, fuel, oils, hired farm labor, interest expenses, and yes, chemicals purchased it increased 34% on average across this time period. And yeah, chemicals purchased or pesticides is one of those things. You guys, if you are farmers, are living this every day. So margins are very thin for many farms. In 2022, almost 2/3 of farms in New York State experienced a net loss. It was just over a third of farms experienced a net gain. The way this is playing out, not just in New York, but across the country, is that these thin margins are resulting in fewer farms. Yes, there's consolidation of small farms and turning into bigger farms, but there's also farms that are just flat out going out of business because margins are so thin. I don't know what Iowa is doing, something right, I guess. They're the one state that's green here and actually is increasing in farms. All of the other states that are in red or some shade of light red are losing farms. So here's a question for you. When money is tight and you might literally lose the farm, is it prudent to be risk averse? I mean, it's kind of a rhetorical question, right? Of course, it's prudent to be risk averse. What is one way to be risk averse? To control pest populations with pesticides. So it makes a lot of logical sense for farmers to be using pesticides as a risk aversion tool. So here's our challenge, at least my and Alejandro's challenge, and a lot of the folks that we work with. How do we support farmers to adequately control pests while minimizing non-target impacts? Because you saw how I introduced this talk, we are absolutely having non-target impacts on biodiversity. But we also need to support farmers to have very low risk, right? To be able to farm their land. Another way of putting this is how do we navigate risk, information, and disinformation, because a lot of that is out there, to build knowledge and trust in the farming community and in us researchers who are trying to support the farming community. The simple answer is it took and it is taking a village, and that's really what we're here to talk about. These are just some of the people involved in this particular topic that we're talking about today, the neonic legislation. One person I want to give a shout out to is Travis Grout. He'll be featured later on really developing the cost benefit analysis that we provided to the state of New York. Julia Suarez is our associate dean for land grant affairs at Cornell, has been really instrumental at bringing the research to stakeholders, not only throughout New York, but also to folks in Albany, for example, our governor, and then Alejandro and the Cornell IPM program you will hear after this. He's gonna have lots of great information. Okay, so to dive right in, we have this new evidence-based neonic policy in New York. We are going to be the first state in New York to ban neonic treatments on corn and soybean seeds. I'll show you what went into that decision. It'll be effective in January 2029, and critically, it provides a $2.2 million allocation to New York State IPM, now called Cornell IPM, to develop and evaluate a predictive tool for corn and soybean pests and neonic alternatives. So we're trying our hardest to have this be not only evidence-based legislation, but also not just make it so that tiny fraction of farms that actually do have some risk, as you'll see later, actually have to keep that risk, but we're trying to eliminate that risk as well with this predictive tool and neonic alternatives. All right, so this is the story. Again, I'll introduce this, and Alejandro will kick in with all of the great data that's being taken over the past couple of years and will continue to be obtained until 2029. All right, so let's start with neonicotinoids. Everyone who I talk to on this topic says, "What is a neonicotinoid?" Well, here is what it is. So it's literally new nicotine or neonicotinoid. The chemical structure for neonicotinoid insecticides, as you can see here, is based off of nicotine, which was a pesticide. It was used previously as an insecticide. The chemical industry has now, or various chemists in various companies have added things to this nicotine structure to make it even more toxic to pest insects. Okay. As of 2026, it's the most used class of insecticides in the world. This is one reason to focus on neonicotinoids. And it's also the most toxic insecticide to bees that exists. So the nitroguanidine neonicotinoids have LD50s, or the lethal dose for organisms, around 3 to 4 nanograms per bee. What that means is that a thousandth of a thousandth of a thousandth of a thousandth of a gram is enough to kill a bee. So really, really toxic stuff. There have been restrictions on neonicotinoid insecticides due to unacceptable risks to manage honeybees and wildlife in many other parts of the world. In 2013, the European Union prohibited the use of neonics on pollinator attractive outdoor crops. In 2017, so about 9 years ago, Ontario, just north of us in Canada, restricted the use of neonics on corn and soybean seeds. In 2018, European Union followed their 2013 decision and actually prohibited use on neonics on all outdoor crops. That stands today. So since 2018, no one in the European Union has been able to use neonicotinoid insecticides. And then in 2019, Quebec, our other neighbor to the north, restricted the use of neonics on corn and soybean seeds. So you can see corn and soybean comes up many times here, and that's where the evidence was really leading us in New York as well. Okay, so we were actually, this was before I had tenure at Cornell, and I was approached by the Cuomo administration in 2018 to perform a formal risk-benefit analysis for neonicotinoid insecticides. I honestly have no idea why the governor's administration was interested in this topic. I'm guessing it had something to do with the legislation that was going on in other areas around this time. But we decided that if we were going to do this, we were not just going to, put a few pages of fluff together summarizing what other people had done. We were going to do the formal risk-benefit analysis that needed to be done in the world. We were going to put our mark on this particular area. So we poured our hearts and souls into this. Took 2 years. We published in 2020 and produced a 432-page comprehensive risk-benefit analysis for every single application context in which neonics are used. And again, Travis Grout, who is up here on the left, he's an agricultural economist. He really took the lead on this. So I only have about 20 minutes here, so I'm not going to tell you everything about this, but just very briefly, the methods for our risk-benefit report. We compiled every relevant study published in the peer-reviewed literature and university extension literature. That includes 327 peer-reviewed studies for risk to pollinators and more than 5,000 paired field trials of neonic versus controls that assessed impacts on pest populations, crop damage, or yield. For risk to pollinators, we went beyond what the EPA does. They look at they focus on the lethal impacts on bees. We looked at the sublethal impacts on bees, impacts on bee physiology, behavior, and especially reproduction, because reproduction is super important for population dynamics. Okay. In most application contexts, there's surprisingly little data to make firm conclusions regarding risk. That in of itself is actually a really important take-home message from this report. You would think we would know more in most application contexts, but we actually don't. We have very poor understanding of risk, again, in most application contexts because there's very little data that's out there. And the other main conclusion of the report is there are clear economic benefits from using neonics in most application contexts, though alternatives do exist. Okay. But that's not true for all application contexts. So here I'm showing you field crops exposures. This is when a colony of bees is placed next to a corn or soybean or wheat field. And what we looked at in the literature was what type of exposure occurred when those colonies are out there, what kind of pesticides do they bring back in when you have neonic treated seeds, and then looked at those levels in terms of their proportion of likelihood of impacting either behavior, physiology, or reproduction of the bees, these three categories. So what I'm going to show you here is all of the data that had been published as of 2020. Any individual data point that is above this red dashed line means by definition there is risk. There is likelihood that the exposure that the bees were experiencing would have impacts on behavior, physiology, or reproduction. All the data below that red line, by definition, means that there's no risk. It would be below a level that has been shown in the literature to impact any of those three things. How does the data come out? It's a mixed bag. So it's not like there's always risk. Excuse me. It's not like there's always risk in these fields crop settings. But overall, 74% of the time, there is likely to be impacts on bee physiology when these colonies are placed in around corn and soybean fields. A little over half the time, it's impacting bee behavior. And then this key response for population dynamics of bees, which is really what we're trying to address with risk assessment, about 37% of the time, there are exposures, excuse me, there are exposures that would be likely to impact honeybee reproduction. Okay? So there's the literature on, all the studies that have been done on this topic. Great to know that. But why else would we want to focus on neonic usage in corn and soybean fields? If there are any field crops farmers on the call, you know what's going on here. This is planting and a little bit of dust getting kicked up. Okay. We know that about 79 to 100% of cornfields and the majority of soybean fields are planted with neonic treated seeds. An initial study that looked into this by Maggie Douglas and John Tooker found that, right around 2003 is when these seed treatments started to be adopted it started to be adopted, and then they started to really take hold in the United States and elsewhere throughout the world. So you can see maize or corn is represented in red here, and soybean is in orange. And all of a sudden, by 2011, it's more than half of neonic usage throughout the world. Okay. That went along until 2014, still the major use being corn and soybean. And then all of a sudden in 2015, unfortunately, we just stopped taking data at a national level. So you can see this very clearly when, in 2015 when USGS stopped monitoring neonic seed treatment usage. And all of a sudden, neonic, usage throughout the world drops. I'm sorry, this is US agriculture drops. Well, that's not actually true. We just stopped taking data on it. So where are we today? Forecasting out through actually 2026. I need to add a year to this slide. We frankly have absolutely no idea. So we don't monitor neonic usage on seed treatments throughout the US, even though this is the major use of neonicotinoids in our country. Our country currently, again, does not monitor the major use of the most toxic insecticide used in the USA. And because of that, we have no idea how much neonic we're putting into the environment right now. So what happens when we put neonicotinoids into the environment? About 2 to 3% of the neonic gets incorporated into the plant as that seed germinates and starts, going into the plant. You can see that in this really nice diagram by Christian Krupke and John Tooker. The purple here represents the neonicotinoid coating on the corn, and you can see this sort of, halo of purple around the crop here. It's about 2 to 3% that's taken up. This is providing protection for about 2 to 3 weeks, that initial, growth stage of the plant and protection of the seeds. The rest, around 97 to 98%, goes into the environment. So 2 to 3% is lost as dust during planting. If you remember the photo that I showed before, most of that's just dust, from the dirt that's getting kicked up during planting. But about 2 to 3% of the seed treatment is also in that dust. It oftentimes gets blown to the side of fields. every year, I work at the Dice Lab for honeybee studies. Every year, I'm contacted by about 10 beekeepers in New York State with acute bee kills that occur at around this time, very likely due to planting dust because they're usually next to corn and soybean fields. Okay. 90% occurs just through leaching. So it comes off of the seed and leaches throughout the soil and it gets into surface waters and groundwaters. The half-life of neonicotinoids is usually in this neck of the woods is usually around 6 months. So about 50% of the neonic will be lost in soils after 6 months. Um, at the extreme end of things, the half-life can be up to 10 years in soils. Okay, and again, planting dust and non-crop flowers are the major exposure routes for bees. So basically, the point that I'm trying to convey here is that the data show there are major risks to bees from usage of neonicotinoid insecticides, especially around corn and soybean fields that are using neonic treated seeds. So if there are major uses or risks to bees and other, non-target organisms, presumably there must be major economic benefits to farmers, right? Well, it turns out there's actually limited evidence of benefits to farmers from neonic treated corn seeds. So this is based on 613 field trials that Travis compiled. And what you can see here is the difference in yield when using a corn seed that has a neonic treatment on it versus a completely naked seed. That's what this is showing. And then it turns out, well, there's a lot of other treatments that are going on seeds. If you're a farmer in the audience, you know that it's not just a neonicotinoid. Almost always there's a fungicide on there. That's what this is showing. So a neonicotinoid plus a fungicide compared to only a fungicide treated seed. And then there's nematicides, bactericides, other things that are often used. But basically, the story is the same. You can see a lot of gray in both of these pie charts. What that means is there's no difference in yield in comparing the neonic versus whatever control you have. Overall, 12% of trials observed an increase in yield compared to controls. If you then take into account the cost of the neonic, because they're not free, right? You're paying for the neonic. About 50% of those trials make up for the cost of the seed treatment. So about 6% of farms are benefiting economically from using treated seeds on corn. In other words, about 94% of farms are actually losing money by using neonic treated seeds. One other thing, I didn't put this in text here, but just to convey is a lot of these studies artificially augmented pest populations. Okay, so they wanted to see if there really was a benefit of neonics, so they added pests to the fields or managed them in a way to really cultivate pests. In the real world, if it was just random fields that you went out to, it would very likely be less than this that were benefiting from neonic treated seeds. Okay. So that's corn seeds. How about soybean seeds? Yes, I did actually change this slide, but you can see basically the same story. A lot of gray in these pie charts. So this is based off of 573 field trials that we compiled as of 2020. 14% of the trials observed an increase in yield compared to controls, and about 50% of those trials made up for the cost of the seed treatment. In other words, about 7% of farms were benefiting economically, or 93% of farms were losing money. Okay, and the same story here with corn. Many of these trials involved artificial augmentations of the pest. Okay, all right. So hopefully you can see from that data, from again, review of all of the literature that had ever been done on this topic, that there's pretty low risk of the pests, actually having a problem or resulting in a problem for farmers. I think this really gets to how neonicotinoid seed treatments are used. They are used as inexpensive crop insurance. And that's just me saying that. That's people at the Farm Bureau saying that. So here is Ashley House, the Vice President of Strategy for Advocacy at the Colorado Farm Bureau. Here's her quote: "We really see neonics and coated seeds as an insurance policy." And it makes logical sense to use it as insurance policy because of how I introduced this talk, right? Margins are very thin for farmers, and it is, even if there's just a tiny fraction of risk that there might actually be a pest problem, you want to eliminate that completely because you want no risk as a farmer, especially when margins are really thin. Okay? So, with that, I'll wrap it up and hand it over to Alejandro to talk about how we're trying to essentially eliminate that risk. Okay, so not just take the time, yeah, it might be 6% risk, but we're trying to make it zero risk for farmers to potentially move beyond neonicotinoid insecticides. Or if there is a predictive tool that's working out there and neonics really are the tool to use, then great, use them in a place that is actually going to be high risk. Don't use them in places that are going to have no risk whatsoever. Okay. So with that, I'll wrap up and just say, well, actually, sorry, one more slide, just because I had a nice photo to put in here. We're interacting a lot this past summer, this current summer, going out to lots of the different plots that we have put throughout New York State. So there's 56 farms that are collaborating on this really large study, 2-acre field plots. This is a 3-year study. It's the largest neonic field trial that has ever been conducted in the world. And we're trying to do this predictive pest model and neonoc alternatives to have farmers' backs, right? So we're working in New York to try and gain trust among farmers on this and show in their backyards, in your backyards, if you're a farmer on the call, what's going on when you use a neonic versus not. All right, so I'll wrap up there and pass it along to Alejandro. Deb, do you want to do questions at the end, maybe after Alejandro is done?
I think so. I think that makes
Okay,
sense. Thank you for that very good presentation.
great.
Thank you, Scott. And I am going to share my screen. Is that coming through okay? All right. Good morning. Thank you, Deb, Kevin, and Jerry for the invitation. So I'm going to take the next phase of this presentation is kind of a historical overview of the legislation and what actually the legislation means. And then I'm just gonna spend a little bit more of time sharing with you guys about the efforts by Cornell University to prepare the growers to transition away from neonicotinoid seed treatments in 2029. So first I'm going to explain the legislation and then I'm just going to talk about the projects that we have. And there's 2 phases of those projects. We started with really a small plot size, lab work and greenhouse, and then we move into that monster large plot setup for doing on-farm research and demonstration. So Scott alluded to that on his presentation, and I have to give a lot of credit to Scott and his team because this is what happened in New York was very unique. I mean, we've been doing this for over 8 years now, and it took some time for the state and the legislators to process all the information from that report that Scott provided in 2029. And with all that information, it just led to drafting a legislation that it was introduced and signed by the governor in 2023. So it took a little bit of time for the governor to sign that legislation. And there were some compromises, but we feel that it's a very well-balanced piece of legislation. And it is the first in the US that it prohibits the use of neonicotinoid seed treatments. And also, it's probably the first, one of the first legislation that is heavy on the IPM component. And I really want to make emphasis on that because it really is allowing us to go back to basic IPM principles. And the basic IPM principle is you have to determine and define the risk of having that pest in your crop before you use any kind of tool. So the legislation is called the Birds and Bees Act. Is like anything with legislation is very complicated. There is 2 sections of the legislation, what that impacts seed treatments. And there is another piece of legislation that impacts the use of neonicotinoid insecticides for ornamental and turf applications in non-agricultural setups. For this presentation, of course, I'm going to focus on the seed treatment portion. And the section is the 371101 in the Environmental Conservation Law. So basically, the law says it prohibits the sale, use, or distribution of any corn, soybean, or wheat seeds coated with neonicotinoid insecticides. And they're very specific on the active ingredients that those seed treatments are being applied with. Clothianidin, imidacloprid, thiamethoxam, or any other neonicotinoid. So there is, I think that Scott might have mentioned this in his presentation. There's almost 7 types of active ingredients in that neonicotinoid group. So all of them are going to be restricted. So what is interesting about this legislation is that it's not a blanket ban. So that means that the growers, they have the option to apply for a waiver and continue getting access to those seed treatments. And going back to my comment about this is very unique in the sense that is allowing us to go back to IPM principles, is that waiver has an IPM requirement. So that requirement is they have to complete a pest risk assessment, and they have to show there is a significant risk of having that pest in their crops. The way they're going to do that risk assessment is with a tool that we're developing in Cornell University that is going to allow to forecast that pest at least 6 months in advance. Because as you know, field crops, they have to plant corn, soybean, they have to place the orders in the fall for start planting in the spring. Also, part of that waiver request, they have to undergo an IPM training. They have to complete a basic IPM training that it has to be completed and submitted along with the pest risk assessment. So the state, the New York State Department of Environmental and Conservation, they're the ones who review that request and they approve that waiver. So if they approve the waiver, they can get access to those seed treatments with neonicotinoid insecticides. That waiver is for a 2-year period. And if the growers want to continue getting access to those seed treatments, they will have to go through that cycle once again. One thing that I want to also point out is that the legislation, it mentions corn. It does not separate corn for silage and sweet corn. So it does impact the entire corn group. So it not only impacts field crops, but also impact vegetables. So Cornell University is in collaboration. This has been a massive effort between the Department of Entomology, the Extension Service, Cornell IPM, and other faculty around the system for developing this risk assessment tool. So that's a risk assessment tool is going to be housed under our Cornell IPM NUA system, that is a pest forecast system. And we're going to try to make this as easy as possible for the growers. There will be a place where they can conduct the risk assessment in their property. They can complete the IPM training that is required. But also, as we go in this process, we want to continue getting information about any damage they see on their fields. So it will be a centralized system where the growers, they'll have access to all these platforms and complete that waiver process. So I have to share, and again, kudos to Scott McArt and his lab, because we already have an IPM training framework for 2029. As I mentioned, that legislation is complicated, and that section for ornamentals and turf, it has the requirement of the IPM training. So we were, in the law says, if you go and read the law, we were required to develop that IPM training and have it ready by 2025. So Scott and one of his PhD students and myself, we put together this IPM training. It's live in our pesticide safety education website, and it's going to serve as the framework for the IPM training that the growers will be required to take in 2029. So it's just a quick snapshot. I mean, it's been, we have already more than 400 people that have taking and completed that training, and they also have to go through some process for continuing getting access to those neonicotinoid treatments for turf and ornamental non-agricultural production. So it's been a really successful platform. We've seen an increase in the knowledge on basic IPM principle and neonicotinoid insecticides that is very valuable in the state. So now, just kind of getting into the most important thing right now is just to share what we are doing to help the growers be ready in 2029. So there's 2 phases of what I'm going to share today. We started in 2022, and that was before the legislation was signed by the governor. And we started with really small plot setups, doing lab work and doing some greenhouse work, looking at, again, kind of defining the risk of having those pests when you have neonic seed treatments and when you don't have neonicotinoid seed treatments, but also looking at some other alternatives and the impact of agronomic practices on pest pressure. And then in 2025, we started the large on-plat farm research and demonstration project that I'm going to share a little later. So I want to focus for now on the small plot lab and greenhouse research. As I said, we started in 2022 and it went to 2024. And I really want to acknowledge all the people that has been involved in this project since 2022. It has been a beast of a project. I've never involved in a project like this. The amount of coordination, collaboration, and work has been, I cannot describe how difficult this has been. But also kudos to every single person and lab in Cornell University that has been involved in this project. In 2022, we established an officially neonicotinoid task force team ahead of the legislation. And that's basically served as a framework for developing this massive project that is ongoing in New York State. I really want to recognize all of these guys in this picture, in particular, Dr. Katia Poveda and her lab. They're being basically the backbone of this project, the small plot as well the large plot project, and as well the extension specialists in Cornell University. This has been a true team effort, and I think we're in a very good shape and very confident that the growers are going to be ready for transitioning away in 2029. So kudos to this group, and very proud to work with these colleagues. So we started with basically 6 projects in 2022 that it ranged looking at basic things. You know, are we using the right trapping system for tracking and monitoring the pests? We were looking at early development of the risk assessment tool. There was something already in place that we needed to see if it was working or not. We look at the impact of agronomic practices on pest pressure. As well, we look at alternatives to seed treatments, chemical and non-chemical alternatives, including novel seed treatment evaluation. So, monitoring, forecasting, risk, and alternatives. So the first thing that we did, and this was Dr. Poveda's lab, was looking at monitoring tools. And we started really big, looking at almost more than 80 sites across the state. This is something I really want to emphasize because most of the data in the past related to seed pressure and the impact in corn and soybean, it was done on very small plots. And most of the time, they were even not replicated. It was 1 or 2 locations. We wanted to get a really good coverage of the whole state. So this was very important from the beginning. We needed to get a good coverage from the whole state. So they started looking at 83 sites and ended up on 46 sites in 2024. The first thing looking at common sticky traps. So in the past, yellow sticky traps, and I remember my grad school days, long time ago, the yellow sticky traps were kind of the standard for most monitoring most dipteran species, including seed-corn maggot. Quickly, they realized that the yellow sticky traps that many people have recommended for monitoring many pests, including seed-corn maggot, they were not very effective. So they started looking at blue sticky traps, and you can see the data has resulted in a publication that blue sticky traps were superior in detecting adults of seed-corn maggot. Then we were looking at forecasting seed-corn maggot. So we're focusing mostly on seed-corn maggot because when we came to this problem, seed-corn maggot has been the driver of seed treatments, or is being claimed that at least for the Northeast, that's the driver pest for using seed treatment. So we have dedicated most of our efforts on seed-corn maggot. However, we're looking at another pest, including wireworm and white grubs. But this presentation is going to focus mostly on seed-corn maggot. So there has been tools already developed 30 years, 40 years ago, degree-day models, that it does provide some prediction of the risk of having that pest. Again, like with the sticky traps, they quickly realized, Dr. Povera's lab, and in collaboration with IPM specialists, they realized that those degree-day models were significantly off. So they adjusted that model. There is a model that is being revised and is already available in our newest system, the pest forecast system. The beauty of that model is that we now have an updated model. However, it's not a very useful model because, as I said, the growers, they need to forecast the pest and define the risk really, really early in the fall season so they can place the orders for planting in the spring. These models that we have right now only give you a 10-day window. So that's basically a useless model for the growers to use. Some more data, they continue looking at the degree-day model and validation of the degree-day model that they also revise. All that is available under our newest system. It also helps for another crop systems that are not as complicated in terms of planting and coordination as corn and soybean. And yeah, so this is a snapshot of the forecast, the seed corn maggot model that is available under our newest system. So this is a good framework, though, because it's going to, what we're doing right now is building a model that is going to allow us to predict the risk of having that pest at least 6 months in advance. So all this work that they did was very important for getting to that point. So the other thing is, what is the risk and what is the damage of seed corn maggot? And Scott, and this is nothing new. I mean, this has been said for over 15 years, that the risk is very low. And in the work that it did in the small plots in 2023 and 2024, looking at the abundance, but also looking at the damage, we didn't see a direct relationship of the abundance that we were seeing on sticky traps, but the abundance that you were seeing in the soil, the seed corn maggots, larvae, and pupae that we were finding on seeds, and how that was translated in damage. So those small plots, the risk of damage was very, very low, less than 1%. And this was looking at corn, soybean, and lima beans. Lima beans is a really extreme crop. I mean, lima beans is not widely grown here. The focus is corn and soybean. Lima beans was selected because seed corn maggot is highly attracted to lima beans. But even with lima beans, the risk compared to the big magnitude or big scale is not that very high. They also look at different setups in the field, looking at using lima beans and corn, looking at different treatment setups. So we look at the conventional neonicotinoid seed treatment. We look at a treatment only, a diamide with a fungicide, and then we look at no insecticide treatment at all. And we couldn't find any significant differences. And when there was a little bit of numerical response, we found that less than 3% risk was determined for lima beans and less of 1% for corn. Which to me, I gotta make kind of a funny joke. You know, this pest is seed corn maggot. I don't think we have to probably rename that pest because it's not really a pest of corn seeds. Another thing they also looking at agronomic practices on the impact of the pest pressure, no cover crop. The same pattern that we have seen on and on, finding less than 0.01% damage on those plots without neonicotinoid seed treatments following cover crop and no cover crops. And the use of fertilizers, manure, alfalfa mixture. This is an ongoing project that Dr. Kathy Povera lab and one of her students is looking right now. Again, there was no statistical differences. We didn't see any strong influence of any of those agronomic practices. on the response of seed corn maggot abundance in New York State. We did some lab work as well, just going back to some basic research looking at different treatments, insecticide seed treatments. We look at the conventional seed treatment with neonicotinoids, the diamide, but also we look at spinosad. Spinosad is a relatively old generation insecticide that is mostly used for organic production. But unlike the neonicotinoids and diamides, it's not a systemic product. So systemicity is a bless, but also is a curse, because it is moving in the plant, and that's where it increases the risk to non-impact species. Spinosad, on the other hand, because it's not systemic, it tends to stay around the seed. What we found is that basically diamides and spinosad, at least under lab condition, it provides equal performance as the neonicotinoid seed treatment. What is interesting is once you go into the field conditions, you don't see that strong response. We don't see that benefit that you see under control experiments. So again, we tested neonics, diamides, spinosad, different times of the year, different years, and we didn't see the benefit of any of those seed treatments compared to untreated control. Also, Dr. Jennifer Taylor, she's a professor in the Department of Entomology, has been looking at a very interesting seed treatment approach using plant elicitors, using methylplasmonate, basically induces a plant resistance against different pests. This is some data that was collected almost 3-4 years ago, where she saw a really interesting response of the treatment in relation of the survival of seed corn maggots. Then they took that into greenhouse and small plots setups a few years ago. They continue seeing that response, not as strong as they saw under lab conditions, but this is, for us, it's a discovery process like any other chemistry. If you talk to chemical companies, it might take 15 years from when you notice it, that activity, to when you go to commercialization. And this is the way we're seeing the methylplasmonate. We're seeing some promising results, and it will only not provide some protection against seed corn maggot, but hopefully another pest as well. So just to summarize those small plot work. So the first one, how can we best monitor? Well, if you want to monitor adults of seed corn maggot, the blue sticky traps are highly effective. How can we forecast? So now we have a model that is being revised, is under our NUA platform. That's going to be it is the framework for the model that we're building, that is going to allow the growers to make that forecast at least 6 months in advance. The caveat of the model that we have right now is that only provides a short window of time. And what is the damage by the pest? So under field conditions, we saw small plots again, less than 3% damage in seeds without neonicotinoid seed treatments. Under lab conditions, we see a strong response. So we see nearly 95% damage in seeds without the neonicotinoid seed treatments. We didn't see any clear influence of cover crop and soil amendments on insect damage. So what are the alternatives? So these were preliminary results. So one alternative is you don't really need to use an insecticide seed treatment. We're not really seeing a benefit of using that seed treatment because the risk of having that pest is really low. However, I mean, if there is a need for using an insecticide treatment, diamides and spinosad, they are effective as the neonicotinoids, at least under lab conditions. Again, we don't see that strong response and benefit under field conditions. Methylplasmonate is a good non-chemical lead, or of course, as I said, more field testing is needed. So now I'm going to switch into the other part of this beast of a project, that is the on-farm research and demonstration project that we started in 2025. And Scott mentioned that we were very thankful and lucky to get support from the state to help implement IPM practices and get the growers ready by 2029. So what is involved in this beast of a project? So we wanted to take this small scale project that we've been doing since 2022 and bring it into large scale, more real life situation. And basically what we did is we started recruiting. We started doing that late 2024, recruiting growers. And we were looking for planting corn and soybean in 2 1-acre plots. We wanted to plant 1 acre with the conventional seed treatment and 1 plot with everything that comes in the seed except the neonicotinoid seed treatment. That's the only thing that we were asking to the growers. They could plant whenever they wanted. They could use all the equipment they wanted to use. We were controlling, we have no control on that. So it's really kind of a natural experiment. But also we were providing some incentives to the growers to participate on this. So we're compensating the growers for participating in this project. There is a commitment for 3 years for this project. And again, this funding was provided by the Department of Ag and Markets. And one of the things that we wanted also to be very mindful is that we wanted to scatter the locations across the state. This is, Scott mentioned this, that until 2016, data on pesticide use has been collected. It took us 2 years to get some data just for New York about the use of neonicotinoid as a seed treatments in the state of New York. So we got a pretty good idea where the hot spots, where is been growing the most, but also what is the usage of neonicotinoids. And the idea is also trying to focus the efforts in those counties where there is a significant growth of corn and soybean with those seed treatments. So this is a snapshot of the locations that we have. As of today, we're really close to 80 locations. And we have field corn, soybean, sweet corn, and we're also excluding a snap bean. Snap bean is not included in the legislation, but we just wanted to have some farms included in this study. So we're providing everything. We're providing the seeds. We're compensating the growers. We're collecting information about the growing practices. We're also getting data, socioeconomic data. We have sent a few surveys. The growers, there's an expectation that they help us answering those surveys. We're looking at yield data, adoption of IPM practices. And I have to say that as we're entering a second year, and it has been a very successful and rewarding project. I'm not going to go in details about the setup for each one of those 1-acre plots. And another thing that I wanted to mention is we are providing, starting last fall and this year, we're providing free weather stations to the growers, a set of growers that are participating in this project. So the target is to hit at least 50 stations, 50 farms with the newest station. So, and that's part of that IPM implementation. We want to get the growers start thinking on those basic IPM principles. Just follow the weather, follow the pests, make a decision, the best decision that you can for manage and prevent and manage that pest. Not the other way around, that is that prophylactic or insurance approach with neonicotinoid seed treatments. So this is actually, as of last week, all the weather stations that were actually going into the farms and setting up those stations for the farmers in collaboration with the extension specialists is another massive effort that is being conducted. And so when I said that this is a natural experiment, is because we have a little bit of problem because the risk has been so low in the small plot setups. We still don't have a model because we have very little data of the pest abundance and the damage that you can relate to the damage to make that accurate forecast. So we're collecting a lot of data in those plots so we can predict the emergence, but also the risk in those farms, and looking at many other variables. So air, soil temperature, soil characteristics, the rainfall. That's what the weather data is really important for us because we collect dozens of points that are important for us developing that model. well as the agronomic practices. What agronomic practices are they using? Cover crop, and the field story, etc., etc. So I have some preliminary results from 2025. Dr. Provera's lab still processing a lot of this data. This is on the left, you have soybean. On the right, you have field corn. The y-axis, the average of seed corn maggot per seed. And again, in this particular case, they have only finding 6 seed corn maggot per 100 seeds. So the pest abundance is extremely low. However, if you go out in those fields and you set up those sticky traps, you can see a lot of flights of those adults. So it is a really tricky pest, and we don't really see the risk and the real damage that it was indicated probably 20 years ago. And that was really consistent for both soybean and field corn. This is data on the stand counts. Again, you see a little bit of, or there's differences between the crops, but within the crop, we see no significant differences in the stand counts. And those are done early in the season. So right now, I know the planting was a little late this year. And right now, they're doing the stand counts for those field locations that we have across the state. And again, at the end, it's all about yield, right? I mean, it's that what the grower is caring about. This is data for field corn for 2025. Again, you don't see any differences in yield data between those plots that you have the neonicotinoid seed treatment versus the untreated. So you don't really see the benefit of using that seed treatment. This is extremely important because this is the first time the growers, they're seeing this by themselves. So they're growing this corn and soybean in their fields, and then they're having that wild moment. Last year, when we did those field corn field days, Scott shared a picture. There were some growers and crop consultants that they were very skeptical. And after walking those fields, it's like, oh my God, I don't see a benefit of this. So that's the main thing of those 2 1 acre plots that we're planting, because it's a real life experiment. The growers are getting hands-on. They're planting and learning that they can grow their crops without using this insecticide seed treatment and go back to IPM principles. This is for soybean legumes. Seed corn maggot are more attracted to legumes. And again, we didn't see any differences between the treated and untreated plots across the state. We just continue asking the growers, because we're not recruiting every single grower in the state. That would be absolutely fantastic if we can do that. However, we're asking the growers, we're working really closely with the grower organizations. If you have any issues with seed corn maggot or any other pest in corn and soybean, to please file this report. That is the most important thing for us right now. This is kind of a forensic entomology project, because we got to go back to those fields and trying to understand what is really driving that pressure that translate in a significant damage to the crop. There were some situations last year that some growers were reporting some damage and some significant loss due to seed corn maggot. What I have to mention is that all of those fields were planted with soybean and corn that were treated with neonicotinoid seed treatments. So again, another way to prove unintentionally that those seed treatments are not providing that protection from that pest. So just to summarize this first year, so what is the risk based in 2025 field results in your state? First, the pest abundance of seed corn maggot was very low. We didn't see any significant abundance that it was translated into significant damage in the crop. And this has posed as a problem for us. As I said, it's difficult to predict the risk when you don't have the numbers. We need more data for this. However, I'm very optimistic that we're going to get to 2029, and maybe the growers, they don't even need to go through the problem of getting a waiver, because they're going to build the confidence that the risk is so low that they can grow this crop without using any insecticide seed treatment at all. What is the damage impact of early season stand counts? We basically see none. And what is the impact on yield? That is the most important thing for the growers, is the yield. We didn't see any issues in relation to yield when you were using untreated seeds in your state. So with that, I just have this the last slide. We have a dedicated website that we're updating where we have more information about these projects. We're going to put all the information about these large on-farm projects as well pretty soon. So I encourage you to visit this website to learn not only about the projects, but about neonicotinoid insecticides. And I think that's all I have. And thank you so much for your time and the invitation, Deb, Jerry, and Kevin.
Thank you very much, Alejandro and Scott. Scott's been answering some questions in the Q&A. We could take some questions now. Q&A is pretty easy, and but there may be some questions that we can read out.
There were a few questions that I'm not the expert on, and Alejandro would know more than me. So maybe we could start with those.
Okay, looking at them, trying to look at them.
So here I can go. So Seth Dibley asked, will New York growers be able to purchase seed without neonicotinoid treatment? That is, rather, are the seed companies on board to support their customers' compliance? And I know, Alejandro, you've been pretty active on that topic. I don't know what you might be willing to share.
Yeah, that is a good, very important question. So first, I have to say that Ag Markets, all the way up to Commissioner Ball, they have been working with the seed companies and seed distributors. I mean, they didn't. The fact that this legislation it doesn't go into effect until 2029 was to make sure that we were going to be ready to pull the trigger on this. I have to say that we've been very lucky with smaller companies, and I don't want to mention any names. And there is some work ongoing to make sure there will be seeds available without any insecticide seed treatment. It will have. I have to emphasize this, that we're not going for a completely naked seed. The seeds that will be offered and available, they will have the other things that come with the seeds. So they, of course, they are appropriate trade. Those seeds, they have a few fungicides and some other things that I can't remember right now. So yes, there will be some companies that will be providing access to the growers to untreated seeds. It is a little more complicated for sweet corn. But there is some ongoing work with companies, and the goal is to have everything ready by the fall of 2028 so they can get access to those seeds without the seed treatment, insecticide seed treatment. So yes.
I can ask one more. This is from Mia Park. Curious about how the survey to capture seed treatment use was carried out. Is New York State now collecting these data, or was the survey sent out by extension? I know that there's been a few surveys, but I don't know exactly where all of the information is coming from. Do you know, Alejandro?
I would imagine is the damage report that we have, correct? So, well, it's only Cornell University through extension specialist and Cornell IPN that we have been distributing that survey or advertising that. And I'm not aware of anyone else just distributing that damage report. It has been widely distributed. And some of the data that has been collected is in Dr. Povera's lab. And I know they have been going back to those field locations and trying to do the forensic work on those locations. There is some data from last year that we still don't have. That was it wasn't on our reports, but it was something that was reported by crop consultants. The damage some fields experienced early in the season, and we still have no access to those fields to this point. So I don't know if that answered Mia's question.
And I think, well, she was, I think, wondering about seed treatment use. So who is using
Oh,
the treatments? And
oh,
obviously that
seed
ties
treatment
into
use.
potentially damage
Oh,
as well. But
no, we don't have any data at this point, but the data that we have from the American Seed Trade Organization is it shows the seed treatment use on 2021. So it's more than 95% of the corn and soybean that is planted. It comes with an insecticide seed treatment. But also, I have to say that some are already being planted with diamides as well. So the two insecticides are going as we speak on the ground, which it can be also it can be problematic. But we don't have any data.
There are
sounds
a
good.
couple more questions there, but could we do the poll before people start leaving and then carry on with some more questions?
Sounds great.
So I think we'll be, there we go. So this is an after post poll. So Alejandro and Scott, do you want to look at the more recent questions that have come in?
Or do you want, I can answer one, Alejandro, here to give you your voice a break, and then we can go back to questions for you. So there's a question from Bob Mann here. Do you have modeling to show the predicted improvement in hive loss incidence as the ban comes online and into the future? This is one of the more common questions I get. I was actually giving a presentation on this last night, and it was one of the first questions that I got as well. Other places have not done longitudinal monitoring when they've put restrictions on neonicotinoids in place. So Europe, Ontario, Quebec, the three major areas that I introduced before have not looked long term, before restrictions and after restrictions, if there's been improvements in biodiversity, in reductions in pesticide exposure to honeybees, et cetera. We are laying the foundation for that. So we now have 1 year of data. The idea is to get 2 more pre-restriction, and then hopefully, if we have continued funding, to do 3 years post-restriction as well. So we'll have a 6-year data set looking at whether there are any changes in biodiversity, and whether there are any changes in exposure to non-target, at least honeybees as well. Alejandro, you want to take one of the questions?
Yeah. So I see two that are kind of similar. Maria Marta, Warna, and Bob. And so Maria is, could it be that part of the low abundance of pests and the absence of difference between treated and no treated plots is due to the many years of treatment that suppress the pest and the continuous presence of neonics in the environment? And I think Bob has a similar question. We saw unexpected long efficacy of imidacloprid for control of hemlowoolly adalgid. Might the same effect be present here? A long residual that's not expected. Very good question. So we're doing a few things. We have been collecting soil samples in every single location. So we have a reference of the amount of residue in the soil. We're also trying to get some history of those plots. We thought at some point that's what we were seeing. Some people call it a halo effect. And we have some data that I think that we can kind of mention it right now, that it is indicating that actually there is loss of susceptibility. So we're not really seeing a benefit of having that insecticide, at least in the soil, and we're not seeing any suppression or even control in some locations. And it is a tricky question, because it's really hard to go back to 25 years ago or 20 years when they started planting corn and soybean with seed treatments. And it's hard to say what was the pest pressure back then. There is some anecdotes that growers, they think that the pressure was very high, but again, it's hard to say if what we're seeing right now, the low numbers, are a response of this long exposure of neonicotinoids in the soil. But again, if you go around fields, you see a lot of seed corn maggot on the sticky traps. It's just the amount. I mean, you can visit Dr. Povera's lab, and I'm pretty sure they have saved a lot of sticky traps. So from the entomology perspective, I still think there is a high abundance of that pest in the environment. It's just it doesn't translate into damage. This is a general species. You're planting corn and soybean. I don't think that the seed corn maggot is waiting. Oh, they're gonna start planting corn and soybean today. So hey, lunchtime. It is a you gotta understand the ecology and biology as well of that species. So again, I'm not saying it's not a possibility, but all the data that we have points out to that that's not the case.
I just showed the poll results, and there's a little bit of shift in knowledge, kind of a nice shift about the legislation, but also about IPM in general. An interesting shift in kind of still 2/3 impact on their farmers, but some of it moved to high, very high impact instead of just high. So that's interesting. And I think a few more will be likely to use integrated pest management. So thank you for those, for doing that poll with us. Are there any other questions that you all want to answer?
Think that mostly covers it. There were some follow-up questions. I was typing away while you were speaking, Alejandro, and trying to answer as best as I could, but there's probably some follow-up that could be done for a couple of the questions where you're more knowledgeable than I am.
Yeah, I think there is one question here about do you expect that after a few years, a decade of no treatment, diseases might start doing more severe damage again? And is there a plant insurance for growers that have complied with the use of non-treated seeds? So the first part of the question, it is really hard to say. I mean, it's just we're even having kind of that issue of protecting a risk at least 6 months in advance. So anything can happen. There's so many factors that allows a pest that it was not a problem become a problem. It very well could happen, or it might not. To the second part, we're working on it. So this is more on the state. I think they're looking into some crop insurance. So I think that if we come to the point that, okay, there's like 2% risk of having that pest and having damage that significantly impacts yield, you can apply for crop insurance or get some insurance, be covered by insurance. So that's something the state is looking into that. We're expected to submit some recommendations to the state as part of the legislation, and the crop insurance is part of that recommendation. I think the crop insurance would be kind of the best thing could happen right now, but that's up to the state to decide and how make that work out for the growers.
I think some of the questions that appeared to be open were actually answered during, there was some duplication of questions. So if you, either Alejandro or Scott, have some wrap-up comments, I think we could do that and then wrap up the webinar. It was a fantastic pair of presentations, really interesting. I learned a lot. I hope everyone else did too.
Yeah, no, thanks so much for having us, Deb. And thanks for those of you who are still on. Thanks for joining. If you have any follow-up questions as things sort of filter into your mind that you think either myself or Alejandro, or I guess the unseen star of a show here too is also Katya Poveda in entomology department. Her lab is really involved in this project, gathering lots of the data, and she's extremely knowledgeable. So for folks at Cornell, great, feel free to reach out. And then obviously beyond Cornell at the state level, there's a lot of folks who are knowledgeable as well.
Yeah, no, I echo Scott's comment. And as I said at the beginning, this is very unique for us. I think this is once in a lifetime that you get an opportunity to do this kind of work. and really going back to IPM principles. I mean, this is how we started having an issue like this, and allow us to rethink how we manage a pest. So there's a lot of lessons to be learned, and so it's been a really challenging journey, but very rewarding. And we think that the growers are going to be ready, and that's at the end. That's the purpose, is making sure the growers they can continue growing their crops and be successful.
There's lots of thank yous and appreciation in the chat box. And one of the comments, thank you for all you're doing. Some great work, and other states are taking notice and modeling their policies on your work in New York State's neonic policies. So I think that speaks volume to your work, Alejandro and Scott. Thank you so much for today.
Thanks, Jerry. Thanks, everyone. Let's make some of this gray hair be worth it.
If it was that easy to get rid of, right?
Exactly.
Thank you, everyone. We will send out a link to the recording once that's established, and so you can look back at it. And thanks again, Alejandro and Scott.
Thank you, Deb. Thank you, Jerry, Kevin, Scott.
Have a great afternoon.
Pleasure.
Thank you.
Bye.
Bye-bye.